Welcome everybody to this new PCB Investigator video tutorial. In this video tutorial, I'm going to show you another great possibility to find differences between two indices of your design. So we have already seen the compare design, the graphic board compare, in the first part of this video tutorial series. And now I'm going to show you the database comparison. The database comparison also compares two indices of your design, of your layout, but not in a graphical way. Instead, it lists all differences for components, for nets, and for test points in a separate list views and in a tabled format. So first here is the BeagleBoard version B4, and I just drag and drop another ODB++ design, the B6 version. And this is open in the background now, and I have the possibility to compare components, nets, and test points. Yeah, so let's start with components. So the comparison is done very quickly, and we have a rough overview here that most components are equal, but there are a few of them are different or are only in design 1 or index 1, and a few of them are only in the second index. So let's take a deeper look through this list. Let's start with those components here. So here the location is different. The component R193, R139 is in both designs, but has a different location. Here the rotation is different. Here the whole part name is different and a few more attributes are there. So you get detailed information for each single component about the differences in the properties or in the location or values. We see a lot of components are equal, and on the lower bottom of this list, a few of them are only in the second design. So there are a few new components in the second, in the B6 version. And a few other components have the attribute similar. Similar means in that case that net is different for pin 1, but it's not listed as different, but only as similar. And that's the reason because in the component options, you have the possibility to define the properties which should be compared. And the pin connection is not activated or is not checked here. When I would check pin connection or any other attribute here, so you have all the attributes listed and you can exactly define which one you want to see and which one should be compared to find differences. But if I do it again with pin connection checked, this component R10 would be listed as different. So it should be in this list here, R10. So now the pin connection is for me important, let's say, and that's why I want to have it as different and not as similar. So you have many options to define exactly which properties you're interested in, and if only location or rotation is relevant for you, or if also value, part name, or pin connections are important for you. But with this tool, it's very easy to find out all the difference for the single components. Yeah, we can switch to the second tab, the nets tab. And I say compare nets and sort by the state. Yeah, and we got a list about the different nets, like for example, the PMIC good nets is in both designs, but has only 66% match. And you see in the detailed overview here that the U226 and U5B15 component or pin is in both, but in the second design, the B6, there's also the U162 included. So there are 3 components in that net, and formerly there were only 2 components in that net. So this comparison is done by the net name and gives you an overview about how many pins are equal or where are the differences. For example, here in that case, for this system reset nets, 90% is equal, but in the B6 version, there's one U16 pin 4 added to this net. Yeah, and this is what the net comparison is doing. So finding similar or equal nets and identify the differences. Also, if they are renamed, for example, let's take a look here. There are the same pins in these two netzes, but the net name is different. That's why the net name is written in blue and is also shown to you that the name is different. The netlist itself is the same. So there's 100% match between those two different named netzes. Yeah, and last but not least, there's a test point overview. And for the test point, you have the possibility to define how to recognize test points. If you would use, for example, the test point attribute on copper pads, and if you don't use special components, let's say, then you would have to use this attribute here. If you want to check components regarding the name or another special test point attribute, which is available in ODB++, or you want to recognize them regarding the package name, for example, the package name must start with TP, then you can use these options. And just for doing an example, I will deactivate that one here. The components are listed which have a package or a reference name with TP, for example, in that case. And you see exactly if a test point, let's say here the TP5, is on both designs on the top layer, but is in a different net. So it gives you an overview about locations. So is there a need to adapt your adapter, your test point adapter? That's the background mostly. Are all the locations the same, or all the nets is the same? And here we see there's one more, so the TP9 is new. A few of them are equal, and three of them are different. And the difference is always in the net name. That could happen if the name was renamed, for example. You can check this in the Nets tab. But what I also want to show you, if you have done a DFT preparation, where there's also a video tutorial about this, then you can say I want to use the DFT session in the background to compare. And in the DFT session, we defined exactly all the access points on this design. And if I click compare here, I again have a list of all the test points which are defined in these TP sessions. I see again the three ones here with different netzes, but same location. And I also see the ones which are only in active job or only in compared job. So there are a few of them only in the first, in the B4, and one is only in the B6. So also for test points, for finding out if your test adapter needs some modifications or if it is still possible to use the same adapter for this new index, this tool is also a very, very great thing. So thanks for watching this video tutorial. And again, if you have any questions, please contact us on the email address support@easylogics.de or take a look on our website www.pcb-investigator.com. So thanks for watching and have a great day. Bye.